Welcome back. This is Ink, and in today's video, we want to calculate the average power and the instantaneous power in the capacitor. So our average power is equal to 1 over the period multiplied by the integration of our instantaneous power over 1 period, and that should be equal to 0. And we'll prove that by using our LTspice simulation. And as you know, even without proving that, when we integrate a sine function over 1 period, we'll see that the average is going to cancel out. So a positive and a negative cancel out. Our instantaneous power is equal to the following: the voltage across the capacitor times the current through the capacitor. So this is a previous problem that we did in a video, and we'll link that video in the top right of this video. So in that previous video, we calculate that the voltage across the capacitor is equal to our expression. So in terms of finding our instantaneous power, we have the current through the capacitor and the voltage across the capacitor. So then we just multiply to get the instantaneous power. So let's do that. So that will be equal to our voltage. So that is 256.25. Or multiplying the coefficients times 10. And then we'll have cosine. That should be 377t times sine 377 times t. So we then see that coefficients is then going to equal to 2652. So that's 2652. And you can put that 0.5 on it. And we then think about simplifying here. We know that, let's put that in red, our trig identity. So our trig identity is equal to sine 2t equal to 2 times cosine, and the parentheses contain the same omega t, 2t. Let's put our sine here, 2t. So to get our following expression, we just divide the left by 2. So that means if we're going to divide the left by 2, we would get our coefficient, well, divide by 2, and then we would transform our cosine multiplied by sine to just sine. So that now is equal to sine, and that 2 times 377 will give us 754 times t, and that will be our instantaneous power. So that is equal to 1326.25, 26.25 sine 754, and that is our instantaneous power. So now we have our instantaneous power. We could then go ahead and calculate our average power. But as we know that the average power is going to equal to 0, because once we integrate over 1 period, the positive is going to cancel out because we're going to add the positive and negative. So we can then go ahead and use LTspice to prove that. So let's look at our our average power. So let's look at our average power, and so we're going to look at our average power. I'm going to look at T. So if T is equal to, let's choose, so 1 period, so an LTspice. Let's bring an LTspice up first. That would be better. So where is that at? Okay. So bringing up our LTspice, right? We already have the problem. So we have the voltage, so the sine function, and as I said, you can go ahead and watch the previous videos. And I'll show you how to build a circuit and show you how to set up the voltage and so forth. So in this case, here we have the voltage across the capacitor and the current. So for the power, you see that there's the voltage multiplied by the current. And this is over 1 period. So that would be 16.67 milliseconds. That's 1 over 60. So here, the time is equal to 0.00369 seconds, right? And the voltage or the watt from our average power is equal to the following. So let's even do that again. So to get the average power, you would want to go on your circuit, click in, I think, control on Windows, and it will be options on Mac. So you click control options. So you see this is the current, and then here we get the voltage. So if we click control or options, depending on what kind of computer you have, then you can get the instantaneous power. So here, if we go to the top, which would be the amplitude, we then see that we get the same thing. Let's just put that on the screen. And I think that's it. So if we go up to the top, I don't know if you can see my cursor here, but I can highlight it. So the number that I highlight is the amplitude, maximum amplitude of our instantaneous power. And if we go back and look, we'll see that both is equal to the same. So here we have uh, oh, there we are. I can't really click on that over here. So here we have 1.326 kilowatt, and here we have the same thing. So we have 1.326. So basically we have 1,326 watt. So that would be 1.3 kilowatts. So that's the coefficient here, or the amplitude of our average power. So to get the instantaneous power, I should say. So now if we go back over to LTspice, if we then go ahead and go onto the trace and then click control, I think option again, is it control or option? Okay, so it'd be control. So now if we click control, let me add that to, I think let me change that so you guys can see that. Okay, there we go. So now as you can see, the average is equal to 0. So we have 0 power for the average. So, and we can then, let me change that back. The reason why I'm going to change that back is because I'm going to use the calculator. Let's use our calculator to test this theory, not this theory, but test this out. So on our calculator, we see that if we put in this sense, let me pull that up. There's a lot of going back and forth, so it's pretty interesting. So here we have our expression, and here we have the time. So let's erase this. And as you can see, here's the 460. I guess we'd have to look back for that time again. So let's look back for that time again. So put that back, put this back, and then scroll. So if we scroll, let's just find a random time. So, okay, let's find here. So that would be 0.009111 milliseconds. And then we get 735 watts. So if we go ahead in our calculator and punch in our expression, I don't know how well you can see that, but I'm just going to use it from here because It's a lot easier. So that would be 0.00, and that would be 91119. I just want to punch out these numbers 67, and that would be millisecond. Looks parentheses, and then we approximate. So that would give us, as you can see, 734.8. You round that up, you get 735 watt. So that is how we would find the instantaneous power. So that is the power at instantaneous times. So I guess I did show you the average power. Um, it's the first time transitioning through LTspice and my tutoring Canvas, so it was a little bit tricky. However, though, that is how you would find the average power in a capacitor or the instantaneous power in that capacitor. All right, so I'll see you in the next one. Bye.